All right, hi guys. So why isn't your RAG working? Usually the vanilla examples we see out there are super easy to do. You just split your documents into chunks. You embed those chunks. You create a vector database. You run some cosine similarity, and then you retrieve the most similar ones, and you feed it into your LLM, and that's it. It sounds simpler than it is in reality. There's a lot of fine tuning to do. Not fine tuning in the LLM fine tuning sense, but fine tuning in the sense of you have to get a lot of little things right in order to have a really good RAG working. So yeah, I listed some of the causes here of why your RAG is not working as you'd like. So in order to do RAG properly, we should understand a little bit at least of how embeddings work. Embeddings will turn your words or phrases or text into vectors. Those vectors tend to align in the sense that similar content tends to result in similar vectors, but it's not always the case. And once you understand how vectors work and how cosine similarity works, you can see why it's not always the case that just by ordering your documents or your chunks in terms of cosine similarity to the question will provide good results. It's not always the case, and we'll see why. So once you have those vectors, cosine similarity is just taking those vectors, getting the cosine of the angle between them, and that's it. They should give you an overall idea of how similar these two things are. Usually works fine, but there are some edge cases where it doesn't work well, and in practice in RAG we end up seeing a lot of those edge cases. So here I have this function that will just compare two words and provide the similarity between them. Now, by looking at these first two words, so apple with a big A and app with a capital A and apple with a lowercase a, obviously this one, if you're thinking about the company, and this one if you're thinking about the fruit, these two should be much more similar. Apple, if you're asking a question about Apple, the company, you want the text that comes back to be either about Apple or Microsoft or anything in that realm, and not about fruits. And you can see the similarity between these two words is much higher than these two. Second one, I think this is a nice example. King and is more similar to queen than it is to ruler. And if you're asking a question about a king, and in some text they refer to the king as a ruler, you might end up getting results about a queen more than you'd get about a ruler. Same for this one, 1900s, 1700s, they're just written in sort of the same way, but the 1900s actually correspond roughly to the 20th century. So if any text mentions the 20th century, you like to get these before you get anything about the 1700s. Well, you can see all of these examples. They show how cosine similarity will not always fetch the most relevant results. And in this one, I'm showing an example where it actually works fine. So the CEO of Apple, you want to fetch Tim Cook, whereas the CEO of NVIDIA, for example, is less similar, so that works fine. However, Apple and Tim Cook and NVIDIA are all known entities. If you're working with a lesser known company, this might not be the case. So first thing, understand that you cannot just rely on cosine similarity. You need to use other strategies. We'll see some of them later, but it's very rare that you have a very simple RAG system that just relies on cosine similarity and it works fine. Now, the chunking strategy is also very important. I've seen many RAG projects where just changing the chunking strategy dramatically changes the results. So chunking is essentially taking the document, splitting it into different chunks, into different groups, and then using those chunks to find the most similar ones and to answer your questions. Now, there is this tool that I like, which allows you to visualize your chunkers. So you can select from here the type of splitter you want to use. So let's say I want to use a recursive character and I want to see how it works on code. You can see that, and you can see the impact that chunk size will have. If I'm using this one, for example, I can not only see the size of the chunk, and so here the blue one is one chunk, yellow is another chunk. If I add some overlap, I can also see how this overlap will affect my chunks. So I have this one chunk that starts here up to here, and then the second chunk starts here. Usually the character splitter chunk, or even the recursive character splitter, they work kind of fine with a smaller text, so you can be more or less sure that you're always getting like paragraphs, that you're not splitting text into pieces. But these days most LLMs have a very big context size, so you can pass a lot of text onto your chunks. You can make them very big. However, you're not going to be sure using these that these chunks are actually semantic similar, and being semantically similar is very important when you're doing RAG. And that's why it's a good idea to use semantic similarity splitting. So on LangChain, they're running these on still on the experimental part, and basically what it does, it will split text based on the similarity between them. So you first split the documents into sentences, then you take them together, and then you check the similarity between those sentences. So you tend to split sentences that are not very similar and keep together sentences that are very similar to each other. So that allows you to sort of group your chunks into context, into semantic similarity, and this usually yields better results than the simple chunking strategies we've been seeing before. Now, as I said in the beginning, relying solely on cosine similarity and embeddings might not be the best idea. So I recommend you also relying on keyword search. So you can either use simple keyword search, but it won't it won't work very well either. But the combination of the two works very well. It's called hybrid search. You have your keyword search in one side, your vector search on the other, and there are multiple ways of combining those. Some of these ways include, for example, getting the results of each of the searches and re-ranking them. Some of these results involve just calculating a score and giving some weight to each of the similarities. But either way, vector search will capture sort of the subtleties and the semantic meaning, whereas keyword will make sure that whatever obvious similarities they find, they will make them come up in terms of number of keywords, number of common words between both texts. So contextual metadata filtering RAG is also a very powerful technique. Imagine you have to search through a product catalog. So you have a lot of metadata on the product. You know their price, their brand, their category. Once the user asks a question about a certain product, what you can do is you can call one or even multiple LLMs in parallel to extract information from that request. So what is the brand, what is the price, what is the product category, and then you use that structured output to filter on the metadata. So you don't rely just on similarity, but you also rely on on metadata filtering, which tends to be more deterministic. So this is an example where you have a sort of internal company chatbot that can answer questions about HR, IT, whatever. Let's say all of those documents are stored under different folders. So I have one folder for financial statements, the other one for IT, the other one for HR, whatever. And then given a user question, you can ask an LLM to say, hey, these might be in the HR folder. Or let's say, what were the most important decisions made by the company last year? It might be under press releases, it might be under board meeting minutes. So once the LLM is able to extract that, you do your vector search or your hybrid search, not on all of the documents, but just on the documents that are under this category. So you minimize a lot the chance of error. And I've also seen these have a very good impact. And there's a few ways of doing that. So in the product example I had, so let's say you want to find the products given, their name, their description, their price. There's two approaches. One of them is the structured outputs approach I was mentioning before. So you just ask an LLM to extract, let's say in this case, I want to extract, the season for which the user is asking. So, I'm looking for a jacket for cold weather. Then it extracts winter and fall. And then once you go through these products and try to find a jacket, you've already filtered on seasons. Another way is to use agents. This is more recent. So here I'm using the small agents framework. And essentially you give these agents a tool, which is to query a database, which can be a vector database. In this case, I'm using ChromaDB. And you teach your agent how to run metadata filters on that base. And it's a little bit more complex, but it will allow you to be more robust. So if on the first try the agent doesn't find any product, it might realize it didn't get the category right or something, and then it can retry with other values. It gives you a sort of more robust but also more unpredictable approach. These are two approaches that I've tried. So here you can see the agent sort of reasoning. Once I ask for a scarf that I can use during spring for less than $30, you can see it's calling the query product DB. So it will embed this query and run a vector search, but it will also filter on price and season and category. So yeah, this usually tends to work well as well. Now, another technique that I really like is enriching your documents with context. Imagine this, you have some HR company policy database again, and you want your employees to be able to ask questions about remote work, like is it okay if I work abroad from another country, let's say. And then you have two documents or two files, one which has the company policy for interns, the other one which has company policy for regular employees. Now, if an intern asks the question of what is he allowed to work from Argentina for a month, trying to find the answer might yield the answer without the context of the document. It might just see in the regular employee document that is okay and answered it, but it's not the case. So it's good to enrich the metadata of your documents with a short summary or maybe a long summary of the document which contains that phrase. So hey, for the context, this chunk they've extracted comes from a document that lays out the company policy for regular employees or for interns or whatever. So we have an example here which is using an LLM to write a short summary, very simple, and a long summary. And then when you're processing your text, you can just define short summary and long summary, which are very easy to do, as you can see from the prompt. And once you have that, the metadata, can contain the file name, things like that, and short summary and long summary. And when you fetch documents, you don't give just their content to an LLM, you actually give also the metadata, at least the short summary and the long summary. And of course, if you fetch multiple chunks from the same document, you might only want to provide that summary once for the whole thing, and just provide for each chunk which document it comes from. And finally, how do you test the impact of all of these? How do you compare if hybrid search is best for your use case, or if the embedding strategy you're using, how do you measure that impact? Well, I recommend a very simple approach. You define a batch of a few questions, let's say 50 to 100, and then you use an LLM as a judge. So you send questions and the chunks you've retrieved to an LLM and ask it to evaluate, to give it a grade. So let's go over this. So this is the prompt. You can say, for example, evaluate if the answer given to a question is correct. So it's either 1 or 0. And then you can evaluate it. And then over a 50 or 100 questions, you can get an average of your score. So that gives you roughly a percentage of the answers you're getting correct. And besides that, you can also evaluate your sources. There's a metric, for example, which is contextual relevancy metric, which you can then test over your LLM. In this case, I'm using GPT Turbo, and that gives you also a metric of how relevant those sources are to the context of the question. And you wrap that into a function that can update the parameters of your hybrid search or anything else you want to test, and then you run that over and over. So here I'm testing a lot of different parameters, sort of doing a grid search, and you can then plot the results to see what was the impact of each metric. So let's say when you're doing semantic search, how many documents should I get? Should I get 10, 20? And I can see the impact that has in both the answer and the sources, to see if the impact that it has on the sources is reflected on the impact it has on the answers. In here, for example, you can see that the relevancy score actually increased when you moved from 10 to 20 chunks, but the average evaluation of the answer itself decreased. So that gives you good context on how your metrics are behaving. That's it. So RAG is not as simple as it sounds. You can do a first version very quickly, but in order to get it right, it takes time and it takes tweaking a lot of stuff. And I hope this was helpful to you, and let's keep on building.